I'm going to try to do three more examples of sketching root locus by hand, but two of them I'm going to go through super quick. And I want to concentrate on a kind of a difficult example. Um, Remember, if you want to look at these examples and more on your own time, a copy of my slides is available on my website. And the URL of that is down in the description of the video. Anyway, here is one example I'm barely going to go through. You got poles, the combined poles are at -1 and -3, and those zeros are at -5 and -7. I'm not going to go through everything. Here's step 0. These increments are 2, so here's the one at -1, here's -3, -5, -7, okay? It's going to be on the real line between these two poles, and then again between these two zeros, right? So we know we need to somehow, we're going to have to go, we're going to have two poles over here that suddenly break away at the same point, one going up and back in, one going down and back in, both at the same places. My advice earlier was to think circular-ish. If you want to know exactly where they break in and break out, we need rule 6. I'm not going to go through all these calculations, but it's at -4 plus or minus the square root of 3. Here's the -4, so it's centered here, and whatever's plus or minus square root of 3 is not quite the center of this, but it's going to be circular. It's going to look something like this, and MATLAB confirms. That's just all I'm going to say about that example. One more example. Let's see. We're going to have complex zeros, complex poles. Let's see. 3 poles, so 3 branches. What? Oh, there's another 0 over here. H is over here. So a complex pair of zeros and another real 0. So n minus m is 0. So this guy has no asymptotes. So it doesn't go off anywhere. There's 3 branches starting at these 3 x's, and they're going to end up at the 3 zeros, right? The only place it's on the real line is down here. The probably hard part of this problem, or tedious part of this problem, is computing the departure angles. And I'm not going to go through that. Use your formula sheet, but they look something like this. You can kind of imagine maybe circular-ish here, but they end up at the zeros, right? This guy just goes from that origin right to that 0, and we're done. And these guys curve around kind of circular-ish, following a circle, I could say, and end up at that 0. That's all there is to it. So there's the hand sketch. Here's MATLAB. Okay, now let's spend our time on this guy. Looks simple enough. Here's our L. A double pole at the origin and another pole at -a, whatever a is, and then a 0 at -1. I'm not going to go through all these. Let's look what the sketches look like after a few steps. You got your double pole at the origin here, right? It's on the real line from this pole over to that 0. And what did I say? Let's see what the departure angles from the double pole. They're plus and minus 90. So these guys start out going straight up and straight down, and then they're going to start coming back in. They're either attracted to this 0 or to these asymptotes. And here's what's tricky. Do they go up over to the asymptotes and this guy just comes straight across into the 0? Or do they come back in and then break away again, go up and down the asymptote? It's not super clear. It's going to depend. And here's where we're going to need rule 6 to make sure. Remember, there's also symmetry. The root locus must be symmetrical about the real line. So you can't have anything too goofy. Let's see. Let's go through rule 6. I'm not going to go through the calculations, but you finally get to, here's where the roots of it are. And remember, where there's roots, there might be break-in or breakout points. But if there's no root there, there's no break-in or breakout point. We get 3 possibilities, depending on what A is. If what's in here is real, or if it's greater than 0, I should say, you're going to get 2 real roots at different places. But exactly equals 0, if what's inside square root exactly equals 0, you get a double root. And if it's less than 0, you get 2 complex roots. So no break-in, breakout points. So I picked that. These are plots of that critical point is when A equals 9. That's when you get this 0. And I can look at for A a little bit greater than 9 and a little bit less than 9. I used 8.9 and 9.1. Here's the 3 things that could happen. Well, these guys come off, they go up, they never come back to the real line. They might start approaching it, but then they start approaching the asymptotes. And probably if I use, let's see, something a lot smaller, it would go more straight up and wouldn't come back down close. Right when A exactly equals 9, you get a double break-in point here, double breakout point here. So they all meet at the same place here. You don't know which one is which. Once they meet up, you don't know which is which afterwards. Here, MATLAB says what started out here goes up there, but it doesn't really matter. You could still say it goes straight in, but 2 of the 3 poles, one's going to go up and one's going to go down after that point, and the other one's going to go into that 0. And then here's where it's slightly greater than 9.1. These guys come in, they break in at the same point, but one goes left and one goes right. And this guy goes up or down. MATLAB shows it as going up, but it doesn't matter. So that was kind of funny. That's why you can't always use guessing and intuition. Sometimes you really should check on rule 6 because it could do something a little squirrely. And these were not 4 different cases of numbers. You get 3 totally different things there. That's all I'm going to do on sketching root locus by hand. Let me see what we've got here. Sometimes, remember, I had 6 rules. Not all textbooks have the same rules or number them the same. Sometimes those first 4 rules with eyeballs only are enough, not always. I usually told my students when to use rules 5 and 6. But in a difficult case like the one we just did, you should probably know you really need to look at rule 6 to know. You got to do these yourself. You can't watch my videos or probably anybody else's videos. You got to start getting a feel for this by doing it yourself. You can use MATLAB, but the way I taught it, didn't have MATLAB on the exam, so you still had to know how to do it by hand. This document is available on my website, URL down in the description. I'm not totally done with root locus because we're going to learn how to design using root locus to guide your design. But that's it for doing root locus sketching by hand. Use root locus for design next.